Chapter 15, number 64. A garden hose is attached to a water faucet on one end and a spray nozzle on the other end. The water faucet is turned on, but the nozzle is turned off so that no water flows through the hose. The hose lies horizontally on the ground, and a stream of water sprays vertically out of a small leak to a height of 0.68 meters. What is the pressure inside the hose? We can use kinematics to figure out how high or how fast the water is moving, because we know that 1/2 m for any little bit of water, 1/2 mv squared plus 0 potential energy is going to equal 0 kinetic energy plus mgh when it gets to its highest point. And so v squared is going to be 2gh, which we're kind of used to. And then we can use Bernoulli's equation, and we can say that if the pressure inside is P initial, and the pressure here is P1, which will be the atmosphere, then we know that P0 plus 1/2 rho times 0 squared, because the water is essentially not moving in the pipe or in the hose, equals P1 plus 1/2 rho V squared. And therefore, the gauge pressure, P0 minus P1, is just 1/2 rho V squared, which is 1/2 rho times 2gh, so it's just rho gh. That seems a little suspicious and familiar, but it's actually right. And so we end up with 1,000 kilograms per meter cubed times 9.81 meters per second squared times 0.68 meters, which turns out to be 6670.8, and then kilogram meter per second squared is newtons. Newton meter over meter cubed is newtons per meter square, so this is in Pascal as expected. We have at best 2 digits, so I should probably call that really 6,700 pascals. And one reason for doing gauge pressure, which is what I've done here, and we're subtracting off the atmosphere, is that if we have that the atmosphere, right, that P1 is 1 atmosphere, that's 101 kilopascals, and so I would have to round this essentially to 7. I'd lose a little bit extra because I couldn't have more than the ones placed in kilopascals, and this is 6.7 kilopascals. So you could also say it's something like 94 kilopascals, and that would be about right.